Hello friends, I welcome you in lecture number 4 on ring theory. In this lecture, we are going to discuss this question on ring which was asked in GTU Summer 2022 exam. First, we understand what is this question. We are given the ring which is a set having 4 elements A, B, C, D under the operations plus and this product of ring denoted by this notation. These operations, addition and multiplication on ring, are as shown in the following table. So here we are given this composition table for both the operation. This is for addition operation, this is for multiplication operation. And using this table, we have to answer these three questions. Does it have an identity, that is, whether given ring has an identity or not? What is the zero of this ring? Zero means additive identity of the ring. And third one is find the additive inverse of each of its elements. So first we answer this question. Here we have to check whether given ring has an identity or not. So whenever we are using the word identity for a ring, then we will understand that is the identity for multiplication operation. So it is also known as multiplicative identity. So we just recall the definition of multiplicative identity. Suppose we have a ring R with these two operations, then an element in ring R is called identity of ring R, denoted by 1 or E, such that A into E equal to E into A equal to A for all elements in the ring. If this property is satisfied for this unique element E, then this unique element E is called identity of ring or multiplicative identity of ring. And the notation for multiplicative identity is 1. So we can write in this way also. If 1 is the identity of the ring, then A into 1 equal to 1 into A equal to A for all the elements of the ring. So here for identity we have to search for this composition table for this multiplication operation, and we have to check whether there exists any element such that that condition is satisfied, that is whether this is true or not. If we start with A, then whether there exists any element E which is unique such that A into E equal to E into A equal to A, that we have to check for B, C and D also. This is equal to B, C into E equal to E into C equal to C, and D into E equal to E into D equal to D. So if there exists some element E in this ring such that these four are satisfied, then that element is called identity of the ring. So here we can see for element A, we can see that if we consider A into A, then we obtain A. And for B, we are not getting B written. There is no element in this ring such that B into E equal to B equal to E into B. We are not getting B here in this line. Similarly, there is no C here. So for C also there is no element like E, and here also. If our ring has identity, then in the composition table at least one times we will obtain that element itself if this condition is satisfied. So this means given ring has no identity. There is no element in the ring such that that condition is satisfied. So answer to the first question is given ring has no identity, or given ring has no multiplicative identity. Given ring has no identity with respect to multiplication or multiplicative identity. So this is answer to the first part. Second part is, what is the zero of this ring? Zero means additive identity. That means we have to find out element E in the ring such that this condition is satisfied: A plus E equal to E plus A equal to A for all the elements of the ring. There are 4 elements, so we have to check whether we can find out any element E such that these 4 are satisfied. C plus E equal to E plus C equal to C, and D plus E equal to E plus D equal to D. If we can find out any element E such that these are satisfied, then that unique element is called zero of the ring. So we start with first element. Here we can see, if we consider addition of A with itself, then we obtain A, and similarly if we consider addition of B with A, that is B plus A and A plus B. A plus B is also B. B plus A equal to A plus B equal to B. Similarly, if we consider C plus A, then we obtain C, and A plus C is also C. That is C plus A equal to A plus C equal to C. And for D also we have D plus A equal to D, and here I can check A plus D is also D. Therefore we can say that this A is the additive identity. So whenever we have additive identity or identity with respect to multiplication, we will always have one column which will contain all the elements. Here elements of the ring are A, B, C, D, and we can see this first column is similar to this set A, B, C, D, exactly in the same order. Now the column under which these elements are occurring in the same order, so the element which corresponds to this column is always an identity with respect to that operation. So here this column A, B, C, D appears below the element A, therefore A is the additive identity for this ring. Here you can see there is no column which contains all the elements A, B, C, D with respect to multiplication. Therefore there is no identity element with respect to multiplication operation, because there is no column which contains all the elements A, B, C, D. Therefore there is no identity with respect to multiplication operation. And with respect to addition operation, the first column is exactly same as these elements A, B, C, D, and it appears below the element A. Therefore A is the zero of this ring. Or we can write in this way also, that from table we observe that A plus A equal to A plus A, that is A. Similarly B plus A equal to A plus B is B, and same thing for C and D. C plus A equal to A plus C equal to C, and D plus A equal to A plus D equal to D. So therefore we can write that for any X in given ring, for any X in given ring, X plus A equal to A plus X equal to X, where possible values of X are A, B, C and D. Therefore A is the additive identity, or A is the zero of given ring. which is having these 4 elements inside it, A, B, C, D. So the second answer is, what is the 0 of this ring? Answer is A is the 0 of this ring. Third one is, find the additive inverse of each of its elements. So whenever we have 0 in the ring, we can talk about additive inverse for each of the elements. Suppose x is any element of the ring, then additive inverse of x with respect to addition is y. If x plus y equal to 0 of the ring, here 0 is A, and this is equal to y plus x. If x plus y equal to y plus x equal to 0 of the ring, then this x and y are called additive inverses of each other. So to obtain additive inverses, we have to again check for those elements. Suppose we want to check for first element A. Suppose we are interested in the additive inverse of element A, then we have to find out the element in the ring such that A plus that element will be equal to 0 of the ring, which is A, equal to that element plus A. So that we can find from the table. So here we keep in mind that A is the 0 or additive identity of this ring. So if I want to search for additive inverse of A, I will search in this row and I will search for the 0. So 0 is here, that is A here, and A plus A equal to A. Therefore additive inverse of A is A itself. Similarly for element B, for the additive inverse of element B, I have to look in this second row and I will search for the 0 in this second row. So here 0 is at this place and that corresponds to element D. That means B plus D equal to A, and we can check for D plus A also. So here if we take D plus A, here we have to check for D plus B, because B plus D is A, so I have to check for D plus B. So this is D and B is here, so D plus B is also A. B plus D is A, D plus B is also A. That means additive inverse of B is D and additive inverse of D is B. B plus D equal to 0 equal to D plus B, and A is the self inverse. So therefore additive inverse of A is A itself, and additive inverse is denoted by minus A. So additive inverse of A is A itself, additive inverse of B is D, and additive inverse of D is B. And we can check for C also. For element C, we search here and here we obtain additive identity, which is 0. So C plus C is equal to A. From the table we find that C plus C is A. That means inverse of C is C itself. C plus C equal to A. Therefore inverse of C with respect to addition is C. So here all the elements are having additive inverses. Additive inverse of A is A itself. Similarly additive inverse of C is C itself. Additive inverse of B is D, and vice versa. B and D are additive inverses of each other. So this is the answer to the third question. Find the additive inverse of each of its elements. To find out additive inverse for each element, we have to search in the row corresponding to that element, and we have to search for the 0 in that row. Whenever we obtain 0, we find out the elements corresponding to that 0 and we are able to decide the additive inverse. For example, if we consider for B, then here we obtain 0 and that corresponds to D. Therefore B plus D is equal to A, and here we can see for D we obtain A here, that is D plus B equal to A. Therefore B and D are additive inverses of each other. Similarly for C we obtain 0 here, and that corresponds to C itself. Therefore C plus C is A, and therefore additive inverse of C is C itself. So in this way, if we are familiar with the definition of identity and 0 and additive inverse, we can easily answer this type of questions. We again recall, suppose we have a ring R with these two operations denoted by addition and multiplication, then an element E belongs to R is called 0 of ring R if A plus E equal to E plus A equal to A for every A in the ring R. And for additive inverse, instead of E they are using this notation 0. Instead of writing E they are writing 0 for additive identity for every A belongs to R. And for multiplication we must have A times E equal to E times A equal to A, and this must be true for every element in the given ring. And multiplicative identity in the ring theory is denoted by 1, that is A into 1 equal to 1 into A equal to A. And for additive inverse, suppose we are interested in the additive inverse of some element A in R, then B is called additive inverse of A if A plus B equal to B plus A equal to 0 of the ring. And same thing for multiplicative inverse, A into B equal to B into A equal to multiplicative identity denoted by 1. So this is nice question, and it was asked in GTU Summer 2022 exam. This is all about this session. I hope you like it. Thanks for